Welcome everyone. My name is Dhimandev Goswami and this is my channel, The Common Math. And today in front of me, I have a problem which can be done by anyone of the age who is above 14 years old. And I'll be solving with you too. So let's start and let's first read the question. What is the distance between the centers of the two identical circles in the figure? So let's quickly analyze the figure. So it is okay. Okay, it's a rectangle, right? It's a rectangle since it's first a parallelogram. It's actually a quadrilateral, the outermost figure, right? So quadrilateral with two pairs of parallel lines, opposite lines which are parallel, is known as a parallelogram, right? So, and it's a parallelogram with one angle, 90 degree, isn't it? And so therefore, and since its opposite sides are also pairs of opposite sides are also equal, so it's a rectangle, right? So now we have a rectangle with us, and inside the rectangles we have two identical circles. So if you want to give it a try, you can just pause the video and try it for yourself. And if you want to get into straight away into the solution, then let's go. So first we need to state that given uh, the outer figure is a rectangle, isn't it? We observed it as what they have written, as what they have annotated in the figure, isn't it? So from looking at that, we figured out, we deduced that it's a rectangle. And with that, let's now get into the problem. So I'm marking first the centers of these two circles, right? Okay. So I got the centers of these two circles. Now with these two centers, they're asking us to find a distance. So they're asking me to find this distance, this one. They're asking me to find this distance. I'm drawing completely rough. I'm not using any scales here. So therefore, please pardon my shaky lines. Fine. So along with that, so they want us to find this distance. Now we know this is a rectangle with 5 centimeter and 12 centimeter as the breadth and the length. Okay, so then since it's a right angle, it's a rectangle, so we can find the distance of, we can find the length of this diagonal, isn't it? So the length of the diagonal will be, we can use by Pythagoras theorem. What can we say? Let's say let diagonal length BD. Then according to question, what can we say? That D equals to root over 5 square plus 12 square, right? So this is by Pythagoras theorem, right? So by Pythagoras theorem, we're able to write this, and we can simply write a centimeter here, isn't it? So this equals to root over 25 plus 144 centimeter, and this equals to root over 169 centimeters, and so this is equal to 13 centimeters. So the diagonal is 13 centimeters. Now the biggest thing, why that's why there's an age restriction, isn't it? So at this age, you get to learn about certain things called as tangents, right? We learn about circles and tangents to them. So we have this theorem in which it says that from an outer point, outside, from an external point of a circle, we can draw two equal tangents. Okay, so if I now, let me just change the color of the chalk. What we have here, if I mark these points, these 3 points, let's just consider this one circle. Okay, let's just consider this circle because these two circles are identical, and these triangles, both the triangles are also congruent. We know that in a parallelogram, the diagonal which divides the parallelogram into two triangles, and both the triangles are congruent, right? So therefore, whatever calculations we'll make inside of this circle will be replicated on the other side itself, isn't it? So let's we just mark the points of tangency, isn't it? And I'll mark with red the external points. This is up 1 point, this is 1 point, and this one is 1 point. These are the 3 points. Okay, and now I'm going to draw the radiuses joining these points. So this is one radius, this is the other radius, this one is another radius. Fine. And now I'm going to convert this triangle into one. So this is one triangle, this is the second triangle, and this is the third triangle. Okay, so we have three triangles. So this whole triangle, this whole triangle, let me just name it A, B, C. So okay, I had a call which I had to pick up. So let's continue. So let's name this this big triangle as ABC. Okay, so this triangle ABC, area of this triangle ABC, and let's mark the center, name the center of this circle as O. Okay, so can I say that the area of triangle, let me just hide my face. So area of triangle ABC will be equals to area of triangle OAB plus area of triangle OCB plus area of triangle OAC, isn't it? So it's divided into these three triangles, right? As you can see. So area of the triangle ABC is pretty clear. So now, before moving into the area of the triangle, we are going to apply two theorems. Okay, so two theorems which we'll be applying is, the first one is that we know that the radius is perpendicular, is always perpendicular to the tangent. Okay, and these tangents, let me mark this name as P, Q, R. Okay, so this BR is equals to BQ, this AR is equals to AP, this PC is equals to QC. Okay, so along with that, uh, let's now continue understanding the problem. So now area of triangle OAB will be, what will be area of triangle OAB? It's going to be equals to, its implication first, okay, it implies. So first, area of triangle ABC is what? It's half into 5 into 12, isn't it? It's a rectangle, so it's a right angle triangle. So what is the area of a triangle? It's half into base into height, right? So uh, you can directly say that the height of this triangle, if I look at ABC in this manner, how we are looking at it, so AB is the perpendicular, and that is 5 centimeters, and which is the height, and BC is the base, and the base is 12 centimeters and the height is 5 centimeters, and we multiply half to that, so that will give the area of ABC. Now this will equal to, now area of OAB, okay, area of OAB is going to be half, right, into, now OR, OQ and OP, this all are radius, right? I also consider let them be R, okay, let radius of circle be R, okay. So um, therefore I can write it's half into R, right, it's going to be half into R into, it's going to be AB, right, and AB is 5 centimeters, plus, now area of triangle OCB, that's going to be, okay, I have a call, okay, I had to take this call again. So yeah, so where were we? So we have the circle's radius as R, and we were trying to write down this equation. And next we have half into, so area of triangle OCB is going to be half into R, since R is in this triangles, since R is the perpendicular, here this will be a perpendicular, this will be a perpendicular. So OCB, R is perpendicular and BC, right? And BC. So half into R into BC is 12, right? Plus half, so area of triangle OAC, OAC is going to be half into R, radius is the perpendicular, and base is going to be AC. And AC is nothing but the diagonal, right? And diagonal is 13 centimeters as we have found out. So it's going to be 13. Okay. So now in the next step, I can write half into 5 into 12 equals to, on the right hand side, I'm going to take half R common, and inside I'm will be having 5 plus 12 plus 13. So this half can be cancelled out both sides. So next step we have 5 into 12 equals to R, and 12 plus 13 is 25, 25 plus 5 is 30. So this is going to be 30. This is going to be R into 30. So I can cancel out 5 6 times, and 6 is going to be cancelled out 2 times. So this implies R equals to 2. So I'm going to take a next page. So I got the radius equals to R equals to 2. Now, and just let me clear this space out. Now, we know that the radius is equals to 2. So now if you look at the triangles, I'm going to now make some changes in the figure. Okay, so this is the center, and this was the distance that we had to find, right? This point and this point, isn't it? And we have the circle here. Okay, I just erase the circle. Okay, a little bit like this. Total approximation. So now, if you look at the if you look at the figure, see this in this figure, uh, this if I take distance parallel, if I make this line parallel to the baseline, and if I draw another line here parallel to the baseline, isn't it? This radius. So this both amounts are 2 centimeters, isn't it? Right? Radius equals to 2 centimeters. This amount is also going to be 2 centimeters. Okay. So now let me draw another line perpendicular from the centers of these circles. Right? This is a perpendicular, this is a perpendicular. So these are going to be parallel. Okay. So let it, I name this one as O. Let me name this one as E. Okay. And this is Q. Let's, okay, this might not be Q. And this perpendicular will be F, and this will be G. Okay. So EQFG. So EQFG is a trapezium, isn't it? QFG is a trapezium, or you can also call it a trapezoid. And now in this trapezoid, what we have to find, so in our, according to our question, we have to find EQ, right? We have to find EQ, the length of EQ. So now, as you can see, CG is also going to be 2 centimeters, right? And RO is also going to be 2 centimeters. So GF is going to be how much? GF is going to be equals to BC minus BF minus CG, right? BC equals to 12 centimeters minus BF is twice and CG is twice. So this much centimeters. So this will be equals to 8 centimeters, right? So now let me draw another line from starting from O, another line segment starting from O and parallel to GF and perpendicular to EG. So let me name this H. Okay. So therefore OH equals to GF equals to 8 centimeters, right? Isn't it? And as soon as we uh, uh, as soon as we change this shape, now what do we have here? EG, isn't it? EG is equals to how much do we have here? Yeah. So this perpendicular. So the radius was 2 centimeters, right? Isn't it? So this radius is 2 centimeters. So GH is 2 centimeters, right? GH is 2 centimeters, and uh, GH is 2 centimeters, and your BC, your EG is equals to 3 centimeters. How? Because EG is a perpendicular to BC, and BC, and this is, let's say the quadrilateral name is ABCD. So CD is also perpendicular to BC. So therefore EG and CD are both going to be parallel, right? So since they both are parallel, what do we have here? Since they have both are parallel, this amount is 2 centimeters, right? It's the radius. Okay. So therefore, if this point of intersection is S, so ES is 2 centimeters, right? So SG minus ES will be 3 centimeters. isn't it? SG is going to be 5 centimeters, right? SG is equals to CD, isn't it? So now we have EG equals to 3 centimeters. Since EG is 3 centimeters, your EH is going to be 3 minus 2 centimeters. Okay, why 3 minus 2 centimeters? EH is equals to EG minus HG, and EG minus HG is equals to 1, which is 3 minus 2, which is equals to 1 centimeters. Okay, so let me clear some space out here. So we need OH equals to 8 centimeters. So OH equals to 8 centimeters. EH is equals to 1 centimeters, right? This is 1 centimeters. This is also 8 centimeters. So therefore, and we can see that EH and OH are perpendicular, as we said that OH is parallel to BC. So therefore, it's going to be perpendicular to EG. So uh, triangle EHO is right angled, right? Right angled triangle, isn't it? So therefore, by Pythagoras theorem, OE is a Pythagoras, by applying Pythagoras theorem, and OE is, okay, no, okay, I made a mistake here to show it's not EQ, it is EO, right? The center of this circle, okay? So it's EO. So EO is equals to, OE is equals to EO, which is equals to root over how much? EH square plus OH square, which is EH square is 1 square plus OH square is 8 square. So this is nothing but root over 65, isn't it? Yeah. So therefore, our answer is going to be root over 65. The required distance is EO to find EO, and we have got EO equals to root over 65 centimeters. Thank you for watching. I know it was a lengthy problem, lengthy solution. If you have a better way to solve it, please do give it a try. Do share in the comment sections. And thank you for watching.